Hi, ladies and gentlemen. So now we're looking at 7.5 compound events, and this is our last lesson of Unit 7. So here's a warm-up problem with a joint marginal relative frequency two-way table below, and it says if it is given that the person plays soccer, find the probability that he or she also plays basketball. So what's given to us is that they play soccer, and what we're finding the probability of is if they play basketball. Well, the total number of students that said yes to playing soccer is 0.325, so that's our denominator. The overlap of those that say yes to both is 0.075. In dividing those, I get an answer of 0.229. So compound events. What is a compound event? It's an event that is made up of two or more simple events. So, for example, you could have something like forgetting to do your homework and taking a quiz. It could be rolling an even number and rolling a 2. Events are mutually exclusive if they do not occur in the same event or trial. So it's things that can't happen at the same time. So for example, rolling a 1 and a 2 on the same roll. Right? Those two things cannot occur at the same time. Mutually exclusive events. For two mutually exclusive events, it'd be finding the probability of like event A or B. I describe these as like the or probabilities because you are going to add them together. So if we take a look at example 1, a group of students is donating blood during a drive. A student has a 9 out of 20 probability of having type O blood and a 2 out of 5 probability of having type A blood. For part 1, explain why the events type O and type A blood are mutually exclusive. Well, you can't have two different blood types. You only have one. So those two events can't happen at the same time, so they're mutually exclusive. What is the probability that a student has type O or type A blood? This is an or probability because we're finding the probability of either or event. So we're going to add them together. So we'll take 9 out of 20 plus 2 out of 5. When adding fractions, you should have a common denominator. So the 2 out of 5 can have a denominator of 20 by multiplying the top and bottom by 4. And then that gives us 17 out of 20 for the final answer. But you don't have to write it as a fraction. You can write it as a decimal or a percentage, and that's also okay. Now let's talk about inclusive events. Inclusive events are events that have one or more outcomes in common. So this is where there is overlap. For example, rolling an even number and rolling a prime number are not mutually exclusive because 2 is both even and prime. So how do we calculate these inclusive events? Oh, let's see. That didn't write for you. Oh, there we go. So inclusive events are events that have one or more outcomes in common, such as rolling an even number and rolling a prime number. They're not mutually exclusive because 2 is both even and prime. So calculating inclusive events, how do we calculate the probability of rolling an even number or a prime number? Well, the even numbers are 2, 4, and 6 on a standard die. Prime numbers are 2, 3, and 5. Remember, prime are numbers that are only divisible by 1 in itself, and 2 is the first prime number. 1 is not included in that definition. The formal definition even says excluding 1. Okay, how do we find the probability of this? Well, the number of even numbers is 3 out of 6, plus the number of prime numbers is also 3 out of 6. But we're double counting the 2, so we need to subtract off that one number that we're counting twice. So we're going to do minus 1 over 6. And that gives us 5 over 6. So in example 2, what is the probability of rolling an even number or a 4 on a die? So probability of rolling even or a 4. Total number of even numbers on a die is 3 out of 6 because you have 2, 4, and 6. Probability of rolling a 4 on a die, well, there's only one 4 on a standard die, so that's 1 out of 6. Now 4 is both part of that second fraction and the first, so I'm double counting it, so I need to subtract off the piece that I'm double counting to give me 3 over 6, or in other words, 1/2. All right, the next one, it says, what is the probability of drawing a king or a heart from a deck of cards? Well, the number of kings in a deck of cards is 4 out of 52. The number of hearts in a deck of cards is 13 out of 52. But now we have to think about, is there any overlap? Are there any kings that are hearts, and if so, how many? Well, there's one king of hearts, so we have one card being double counted, so we need to subtract off 1 out of 52. And that gives us 16 out of 52, or the decimal version of 0.308. Because again, I don't care if it's in fraction or decimal form. Alrighty, we are going to skip this one because you can't see all the students in the class. Example 3. The numbers 1 through 9 are written on cards and placed in a bag. Find each probability. Why don't you pause the video, work on this one on your own, and press play to see the answer. So probability of choosing a multiple of 3 or an even number. Your multiples of 3 are 3, 6, and 9 because we're going from 1 to 9. Even numbers from 1 to 9 are 2, 4, 6, and 8. All right, so probability of choosing a multiple of 3 or an even number. Our multiples of 3, there are 3 out of the 9 options. Plus our even numbers, there are 4 out of the 9 options. But do we have any numbers that are a multiple of 3 that are also even, that we're double counting? Yeah, we have 6 that is being double counted. So one number is being counted twice, so we need to subtract off 1/9. And that is going to give us an answer of 6 over 9, which reduces to 2 over 3. Next one, choosing a multiple of 5 or an even number. Multiples of 5 are just 5 if we're looking at numbers 1 through 9, because 10 isn't included. And then again, our even numbers are 2, 4, 6, and 8. So finding the probability that a number is a multiple of 5 or even, well, there was only one multiple of 5, so that's 1/9. Plus our even numbers, there's 4 of those, so plus 4/9. And a multiple of 5 is not also even, there's no overlap, so we don't have to subtract anything. And that gives us 5 over 9. All right, last example. Each student can cast 1 vote for the senior class president. Of the students, 25% vote for Hunt, 20% vote for Klein, and 55% vote for Vila. A student from the senior class is selected at random. Are these events mutually exclusive or not? In other words, can these events happen at the same time, or can they not happen at the same time? Well, a person is only allowed to cast 1 vote. So yes, these events are mutually exclusive. You can't vote for more than one person, so there's not going to be any overlap between the people that are voting for Hunt, Klein, or Vila. Then it says, what is the probability that a student voted for Klein or Vila? Well, the probability that someone votes for Klein is 20%, plus the probability that someone votes for Vila is 55%. There's no overlap, so I don't need to worry about subtracting. So I get an answer of 75%. And that's it. All right, that is all of 7.5. Let me know or Mr. Brasser know if you have any questions. Thank you.